Hello, today we are doing a mini unit on the Pythagorean Theorem. Our learning target for today is I can use and apply the Pythagorean Theorem. So what is the Pythagorean Theorem? Here are our two vocab words. First one is the Pythagorean Theorem, which is an equation or a formula that we use to find one of the three sides of a right triangle. So this Pythagorean Theorem has to do with triangles, and specifically right triangles. I'm going to abbreviate RT for right. So right triangles. If we know two of the three sides, we can figure out the third side. So A and B are always what we call our legs. Just like you have two legs, so does a triangle. And then our third side, which is always going to be the longest side opposite of the right angle, we call that the hypotenuse. It's, like I said right here, the side opposite of the right angle, and it is the longest side. In the equation, we always use the letter C to represent the longest side. So these two legs would be A and B. It doesn't matter which one's A and B, that's up to you. But our equation, we take A and square it, B and square it. If we add those two up, we should get C squared. So here we have really a squared plus b squared equals c squared. They already solved b squared and c squared. We just need to figure out what is x. So these ones are just going to be solving equations. Then in a minute we'll actually use the Pythagorean theorem from the beginning. So if I'm going to solve this like a regular equation, always get rid of adding and subtracting first. I would subtract 14. So then I get x squared equals, well, 10, give us 6, 36. So then right here, to undo a square or the power of 2, use the square root. Just like adding and subtracting are opposites, multiplying and dividing are opposites, the square and the square root are inverses or opposites of each other. So if I take the square on one side, I have to take the square on the other side, square root. So a square root and a square are opposites, they cancel out and leave us with just x left over. So then the square root of 36 is just 6. So 6 squared, if you plug that back in, 6 times 6 is 36. 36 plus 14 does equal 56. The second one, same thing. If I get rid of this 12, subtract 12, we get b squared equals 25. And then to undo the square, we take the square root. The square root and the square are opposites or inverses of each other. They eliminate. And we have b equal to the square root of 25, which is 5. So now let's actually use the Pythagorean theorem from the beginning. It says find the unknown length, round to the nearest 100th if necessary. Remember, 100th is 2 spots after the decimal. So here are our two legs. I'm going to say this is side A and this is side B. C is always our longest side. That's what we're trying to figure out. So I would start by writing our equation, or our formula that we're using, a squared plus b squared equals c squared, and plug in what we know. A is 8, so 8 squared. B is also 8, so 8 squared, equals c squared. We don't know what c is. But each of these numbers we could really put in parentheses if we want and square them. 8 times 8 is 64. 8 times 8 is 64. And then over here we just have c squared. So if we add those two together, 64 plus 64, we should get 128. You can use a calculator if you'd like. So some people are going to stop here, but we're not quite done yet because c is not by itself. We want c, not c squared. So just like we did on the last couple of problems, to undo the square, we take the square root. So square root and a square eliminate. They're opposites or inverses. So now we have c, and I would need to plug in my calculator the square root of 128, which gives me 11.3137. But we need to round it to the nearest hundredth, so 2 decimals. So it would really be 11.31. 11.31 because our next number is less than 5. So 11.31 would be our best answer. Remember to plug this in your calculator, push the second button, and then the x squared button has the square root right above it. That's how we get to those functions. Please ask if you don't know how. Alright, next I'm going to rewrite our equation. A squared plus b squared equals c squared. I know I can use this formula because it's a right triangle. B is what we're trying to find. So our other leg would be A, and our longest side opposite of the right angle is C. So A is 10, so we have 10 squared plus B squared equals 15 squared. So I'll solve this. 10 times 10 is 100. 15 times 15 should give us 225. Remember, it's not 15 times 2, it's 15 two times. 15 times 15. So now we need to get B all by itself. So first I'm going to get rid of my adding and subtracting. Subtract 100. So we have B squared equals 125. We need to get our answer to the nearest hundredth, so we do need to get rid of our square by taking the square root. Those eliminate and leave us with B. And then the square root of 125 is 11.18. Very similar to the last answer. Alright, let's try one more. A and B are already listed for us. We need to find C. So A is 7.5 squared, B is 18, and we need to square it, and then C is what we're trying to find. So 7.5 squared, you can do 7.5 to the power of 2, or 7.5 times 7.5, which is 56.25. And then 18 to the power of 2 gives me 324. I'm just using my calculator. I have it right next to me, so I can plug these in. So add those two together. 324 plus 56.25 gives us 380.25. And we need to find out what C is. So the opposite of a square, the power of 2, is the square root. So that'll leave us with C equal to, alright, we need the square root of 380.25. Gives us a nice 19.5. So now we know how to use our Pythagorean theorem to find one of the three missing sides. We can do the same thing without an actual picture. Find the unknown lengths. So A is 15, so we'd have 15 squared plus B squared equals 25 squared. Some of you are going to think, well, 15 plus 10 will equal 25. That's not what we're looking for. We need to take each of these to the power of 2. So 15 to the power of 2 is 225. Then plus B squared, and then 25 to the power of 2 is 625. So when we solve this, I'm going to subtract 225 to get the b's by themselves. It gives us 400. Well, that turned out nice. So the opposite of a square is a square root. So we have b equal to the square root of 400, which I believe should give us 20. Yes, exactly 20. Alright, this one, for some reason my picture didn't show up here, but let me think. I don't remember what it should be. But we have a squared plus b squared equals c squared. We know c is what we're looking for. We have the square root of a number here. I believe it is 36. If it's not, do this problem with whatever number I have here, and I will fix the video in a little bit. So, if we take the square root of 36 squared, the square root and a square are going to cancel, so we have 9 squared plus 36 equals c squared. And we know 9 times 9 is 81. So 81 plus 36 give you 117. I know this is not the right number. Square root of that will give us 117, 10.82 if we round it. I believe the number, whatever number was here, was a number that would give you a nice whole number in the end. Alright, our last slide here, it says, do these side lengths make a right triangle? So we know a squared plus b squared equals c squared. Now they're telling us the converse, not the shoes. Converse meaning the opposite. Oops. The opposite of the Pythagorean theorem. So if a triangle has side lengths a, b, and c, where a squared plus b squared equals c squared, then the triangle is a right triangle. In the past, the Pythagorean theorem told us if it's a right triangle, then a squared plus b squared equals c squared. So they're just telling us the opposite. If a squared plus b squared is c squared, well then that triangle must be a right triangle. If not, it's some other kind of triangle. So we know c is always our longest side. It doesn't matter which of these two are a and b. We just need to plug them into our equation, our Pythagorean theorem, to see does a squared plus b squared equal c squared. So 15 squared plus 60 squared, we need to see does that equal 61 squared. So 15 to the power of 2 is 225. 60 to the power of 2 is 3,600. And 61 to the power of 2 is 372. So if we add these two together, 3,600 plus 225 gives us 3,825. Oops, 61 to the power of 2. I forgot the 1 in there. 3,721. Those are definitely not equal, so this is not a right triangle. Let's try the next one. C is always our longest side. The other two are A and B. So we have 12 squared plus 71 squared equals 72 squared. We need to see is that true or not. 12 times 12, hopefully you should know that one. 144. 71 squared is 5,041. Again, I'm just plugging these in my calculator. And then 72 squared is 5,184. So if we add these two together, 5041 plus 144, 5,185, which is so close to 5,184, but they're not the same. So this is not a right triangle. Not a right triangle. Let's try this last one. Hopefully this one makes a right triangle for us. 4.5 squared, I'm just saying this is A and B because C is our longest side here, plus 6 squared equals 7.5 squared. So let's type in 4.5 to the power of 2. We get 20.25 plus 6 times 6 is 36, and then 7.5 to the power of 2, 56.25. So if we add these together, 36 plus 20.25, we get 56.25, which is the same on the other side. So because, oops, I can't put a 5 there, 2, 5. Because these are exactly the same, this is a right triangle. So you could put yes for this one and no for these if you want to make that shorter. Otherwise, good luck